The ASUS Mothership has such a unique design that it's not really even a laptop anymore. It's been designed from the ground up with optimal thermals and performance in mind. So let's find out what this powerful machine's got for us in this detailed review. Let's start off with the specs. There's an 8-core 16-thread overclockable i9 9980HK CPU, RTX 2080 graphics, definitely no max Q here, 64GB of memory and dual channel, a 17.3-inch 4K 60Hz screen with G-Sync, and 3 512GB M.2 NVMe SSDs in a 1.5TB RAID 0 array for storage. For network connectivity, it's got 2.5 gigabit Ethernet, Wi-Fi 6, and Bluetooth 5. So we're dealing with top-of-the-line specs here, meaning it's definitely not cheap. You can check out updated prices linked in the description. The Mothership is quite a bit different when compared to your traditional laptop design. Basically, when you place it against a flat surface, 2 buttons are pressed in which deploys the kickstand for the machine to rest on. Straight away, this means using it on anything other than a flat surface is going to be pretty difficult. Think of it more like an all-in-one desktop replacement rather than a laptop. From here, the keyboard is pulled down off the screen. It's held in place with magnets. All of the heat-generating components, like the processor and graphics, are in the thick section behind the screen. The keyboard can be removed completely and used wirelessly too. There's a hinge which allows you to flip it over to take up less space. And the keyboard will automatically charge when it's docked to the Mothership. The build quality of this thing is exceptional. It's made from multiple solid pieces of aluminium which combines both brushed metal and matte black anodized finishes. The weight is listed at 4.8 kilos on the ASUS website, and I found mine a little closer to 4.7 kilos. As my scales only go to 5 kilos, I've had to measure the two 280-watt power bricks and cables separately, which came in at an additional 2 kilos. So in total, we're looking at 6.8 kilos or 15 pounds, not exactly portable. The dimensions of the Mothership are 41 centimeters in width, 32 centimeters in depth, and 3 centimeters thick. So on the larger side for a 17-inch machine, which is kind of expected when you consider the extra cooling space needed for the top tier specs. The larger size also means we've got 1cm screen bezels on the sides and thicker up top and below. The 17.3-inch 4K 60Hz screen has a matte finish, good viewing angles, and we also have the option of disabling NVIDIA Optimus to use G-Sync, which should improve performance at the expense of battery life. Although it can game at 4K, I think most people would have preferred a 1440p high refresh rate panel. 4K 120Hz options are meant to be on the way, but don't seem to be available just yet. I've measured the color gamut using the Spider 5 Pro, and my results returned 99% of sRGB, 92% of NTSC, and 97% of Adobe RGB. At 100% brightness in the center, I measured 431 nits with an 1140:1 contrast ratio, so excellent results in all aspects and a fair bit above average. When it came to backlight bleed, it was looking fine in this worst case, only extremely minor glow that I never noticed during normal use. There's a 1080p camera above the screen in the middle, and it's also got infrared for Windows Hello support. Despite being a 1080p camera, the quality isn't very good. The microphone's okay though. Here's what typing sounds like. And this is what it sounds like when we set the fan speed to maximum. So it gets pretty loud, but you can still hear me over the fans. The keyboard has per-key RGB backlighting, which can be controlled through the ASUS Armoury Crate software, and this syncs up with the lights on the rest of the Mothership using AuraSync. You can also quickly swap through effects and change brightness between 3 levels or turn lighting off completely with the arrow key shortcuts. Unfortunately, the F keys at the top do not get fully lit up. It's got 2.5mm of key travel, N key rollover. I measured key actuation at 62 grams. And as mentioned, can be used either wired or wirelessly. You can enable or disable wireless mode on the keyboard with a switch up the top right, and you can see its charge level in Windows. I used about 10% charge in an hour with RGB lighting on. With the keyboard docked and charging, it connects using magnets to keep it in place. And magnets also hold it up against the screen when you close it up. With the keyboard detached and folded over, there's a Type-C port that can be plugged in so you can still use the keyboard if the battery runs out in an undocked manner. No cable is needed to use it docked. Otherwise, with a charge, it uses 2.4 GHz wireless. As the keyboard has a hinge mechanism in the center, it does move a bit when you press down. There's a cutout ROG logo in the brushed metal, which just seems to be for aesthetics. Overall, I did like typing on the keyboard, despite the hinge flex. Here's how it sounds to give you an idea of what to expect. When you take off the keyboard, it kind of looks like a massive tablet, but there's no touchscreen. This does mean you have room to connect your own keyboard instead though, and it was kind of cool being able to move the keyboard onto my lap with the rest on the desk. There are 4 4-watt speakers found underneath the keyboard, along with RGB lighting, and they sounded great. There was some bass, and they still sounded okay with the keyboard on, but they were clearer with the keyboard removed. They get quite loud at maximum volume, and the latency mon results looked good. Speaking of sounds, it plays this one by default on boot. Fortunately, you can disable this through the Armoury Crate software. The precision touchpad worked okay, however I'm not personally a fan of having it over on the right. I get why they needed to do this though. To have the keyboard moved up, they'd have to remove the ability to fold it, and having a large unbendable sheet would probably be more awkward. The touchpad has left and right click buttons below it and can also be used as a numpad, but when in this mode, touchpad functionality is disabled. Fingerprints show up quite easily on the matte finish around the keyboard, and on the brushed metal finish which is all over the machine. The smooth surfaces were easy to clean, but the brushed finishes were a little harder once dirt gets into the grooves. On the left from the bottom, there are 2 USB 3.1 Gen 2 Type A ports, 2.5 gigabit Ethernet, 3.5mm audio combo and mic jacks, USB 3.1 Gen 1 Type A port, and USB 3.1 Gen 2 Type C port with Thunderbolt 3 support. On the right from the bottom, there are the 2 power inputs, HDMI 2.0 output, USB 3.1 Gen 2 Type A port, USB 3.1 Gen 2 Type C port with DisplayPort 1.4 and a full-size SD card slot. On the front, so underneath the keyboard, there's a brushed metal finish with ROG logo. On the bottom, there are just the 2 buttons that activate the kickstand when they get pushed in, while up on top of the machine there are air exhaust vents. On the back there's the kickstand which keeps it standing upright. It's a solid piece of aluminium and was quite sturdy feeling. By default, the hinge puts the screen on a 105-degree angle, but you can push it back further to 127 degrees. The hinge is stepless, so you can adjust it anywhere between these ranges. The weight of the unit will keep it in place. I had to use my hands to pull the hinge back, but simply pulling the machine forward would automatically retract it. There's an opaque ASUS logo in the middle of the stand, and RGB lighting slightly shines through from behind the stand. Otherwise, there's just a Kensington lock behind the stand. To open it up, you need to remove 7 Phillips head screws from the top and bottom, and 4 TR7 screws from around the sides. The back panel easily popped off for me once these were taken out. We can see there's a dust filter on most of the intake holes, except directly above the 2 fans. Although ASUS apparently has self-cleaning anti-dust fans. Unfortunately, I can't see how this goes without long-term use. Inside, we've got the 90-watt-hour battery down the bottom, 3 PCIe M.2 slots above this below the black heat spreader, 2 memory slots, and Wi-Fi 6 card on the right. You can configure the mothership with up to 128 gig of memory as it's got 4 slots. I've got 4 16 gig sticks here. The other 2 are found on the back of the motherboard, making them more difficult to access. To test the 90-watt-hour battery, I've set the screen brightness to 50% and disabled background apps and RGB lighting. While watching YouTube with Optimus enabled, so with the Intel integrated graphics in use, it lasted for 4 hours and 5 minutes. With Optimus disabled, which requires a reboot, the Nvidia graphics are in use the whole time, which is needed to use G-Sync. It lasted for almost half this, at 2 hours and 4 minutes. While gaming with The Witcher 3 capped to 30 FPS with Nvidia battery boost, it lasted for an hour and 10 minutes and the frame rate didn't drop at any point. You don't need to carry both power bricks with you. You can get away with just a single 280-watt brick for many less power-consuming tasks. But for full gaming performance, you'll want both. With both bricks plugged in, I never had any battery drain during any of my testing. When you swap to battery mode, the screen flashes black as it automatically swaps from the default 60Hz refresh rate down to 48Hz, which should help with battery life a little. You also can't use turbo mode when on battery, more on what that does shortly. Let's move on to the thermal testing. As you'd expect with this level of hardware, we've got some pretty serious cooling, which includes 8 heat pipes covering the CPU, GPU, and VRM, 4 thick heatsinks, thermal grizzly liquid metal, and 2 12-volt fans. Basically, air is pulled in through the back and exhausted out of the 4 vents near the top corners, so no hot air blowing on your mouse hand. This allows the machine to breathe much easier compared to a traditional laptop design, where the fans are squashed right against the desk. The ASUS Armoury Crate software gives us the option of swapping between silent, performance, and turbo modes. These adjust things like power limits and perform overclocking, as specified on screen here, and I've tested all 3 modes. I want to point out that the i9-9980HK CPU has a default all-core turbo boost speed of 4.2 GHz, so overclocking all 8 cores to 4.9 GHz in turbo mode is pretty crazy stuff. You can swap between these modes through software, or by using the function and F5 key, the one with the fan icon. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. At idle, both the CPU and GPU were looking fine. The rest of the results are from combined CPU and GPU workloads, and are meant to represent worst-case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the ASUS CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. Whether gaming or under combined CPU and GPU stress test, the temperatures were lower both in silent and performance modes, as these restrict the power limits, as we'll see soon. Turbo mode raises power limits and performance at the expense of additional heat and fan noise, as you'll hear later. By default, turbo mode overclocks all 8 cores to 4.9 GHz. In my best case test, I pushed this a little further to 5 GHz and applied a small undervolt. This didn't really help the thermals in the stress test, and lowered them by 1 in this particular game. These are the average clock speeds for the same tests just shown. Silent mode had the lowest clock speeds as the power limits were the lowest. Performance mode steps up clock speeds a bit, then turbo mode saw the largest increase. The 9980HK has a 4.2 GHz all-core turbo boost speed by default. So although the 4.9 GHz all-core overclock in turbo mode is not being hit, we're still seeing excellent results and above best case stock performance. My additional CPU undervolt helped improve things by over 100 MHz more. I couldn't push it too far though, as the CPU needed pretty much all the power it could get at this speed. These are the average TDP values during these same tests. In silent mode, we can see the CPU TDP is capped to 45 watts, then 55 watts in performance mode. In turbo mode, we're capped to 90 watts, and this was our limitation preventing further performance. I was not able to boost the TDP higher in Intel XTU when under a combined CPU and GPU stress test. 90 watts on the CPU seemed to be the limit. Don't worry though, as we'll see later in the game benchmarks, the results are still insane. And to be fair, as we saw, this prevented the CPU getting too hot. Otherwise, we can see the GPU was performing extremely well, averaging 195 watts in the stress test and hitting 200 watts at times. Here are the CPU clock speeds while under a CPU-only stress test. The results are higher as the NVIDIA graphics are now idle. Turbo mode was able to hit the 4.9 GHz all-core overclock in this workload, and my manual tweaks got us to 5 GHz over all 8 cores. Pretty impressive. Here's what we're looking at in terms of temperatures. It looks like my extra 100 MHz overclock to 5 GHz is being offset by the small undervolt. This is shown when we look at the average TDP reported by Hardware Info. The CPU was drawing around 115 watts in both tests, so higher than the 90 watt limit that was observed in a combined CPU and GPU load like gaming. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks from these same modes. For reference, a good i7-9750H can get to 3000 points in this test, so we're seeing significantly higher performance with the 8-core i9 in turbo mode, as this overclocks all cores to 4.9 GHz. So how do these different changes actually affect game performance? I've tested a couple of games to find out. Shadow of the Tomb Raider was tested with the built-in benchmark at highest settings. There wasn't really much difference at all. My changes only gave us 1 FPS extra, which makes sense given the undervolt is minor and 100 MHz isn't really much at all, especially when we're usually GPU bound here. Far Cry 5 was tested with the built-in benchmark at ultra settings, and the results were similar in terms of average frame rate. What I took away from these tests was that we can still get high levels of performance from silent mode. And while not silent, the fan was definitely quieter compared to turbo mode, as you'll hear soon. As for the external temperatures where you'll actually be putting your hands, at idle the keyboard was cool. Normal laptops are around 30 degrees in this test. But as there are no heat generating components underneath, this one was a cool 20. The screen does get to 30 though. Looking around the back, it's also around 30 degrees too. With the stress tests going in turbo mode, there's no major change to the keyboard, though the screen is about 10 degrees hotter now at about 40 degrees. Looking on the back, we're seeing around the mid-40s too, while the exhausts are obviously hotter still. Nowhere you're actually touching gets hot, and the parts that do heat up aren't too bad either. The screen was a little warmer than most others, but as I saw at CES, ASUS are placing a metal plate between the heat generating components and the screen to shield it, so they have obviously considered this. Here's what the fans sound like during these different tests. At idle in silent mode, the fan was definitely still audible. With the stress tests running in silent mode, it was actually quieter than most other gaming laptops while still destroying them in performance, as we saw earlier. In performance mode, it's close to many other gaming laptops. And then in turbo mode, it's very loud at around 59 decibels. You'll definitely want to use some headphones here. The results from the ASUS Mothership are extremely impressive. The RTX 2080 also runs up to 200 watts. That's higher than the Alienware 51M, just for comparison. Despite packing all of this hardware, the mothership didn't get too hot either. Temperatures peaked around 90 degrees Celsius worst case on the CPU and 80 for the GPU. Okay, sure, that's getting a little warm, but when you put it into perspective with the performance compared to other laptops, it's very impressive. Next, let's look at some gaming benchmarks. I've tested these games at all setting levels at 4K, 1440p, and 1080p resolutions, with turbo mode enabled and Optimus disabled for best performance. So CPU and GPU are overclocked. Battlefield 5 was tested in campaign mode. At 1080p, even RTX was playing alright, with 60 FPS averages still reached at ultra settings, while RTX off, shown by the purple bars, was getting much higher performance. 130 FPS at ultra settings is pretty crazy stuff. Stepping up to 1440p, and we're still getting better results than what most other gaming laptops are able to provide at 1080p, though the RTX results are now about in line with 1080p results from those other machines. RTX on was still playable at all settings, though much better at medium, and 100 FPS at ultra with RTX off at this resolution is quite nice. At 4K, RTX on is pretty much a write-off at all but the lowest setting levels, making it kind of pointless in my opinion. However, we were still almost able to average 60 FPS even at Ultra 4K with RTX off. Control was tested by running through the start of the game, and again I've tested both RTX on in green and RTX off in purple. At 1080p, RTX on played fine even at max settings, though like Battlefield 5, we could get much higher FPS with RTX off. At 1440p, RTX off still played perfectly fine for me, averaging above 60 FPS at max settings, though RTX on was starting to get a little slower at medium and high settings, but was still usable. At 4K, RTX is pretty much a no-go. However, with ray tracing off, it was still playable at low settings and didn't look too bad. The game looks quite decent even with the low preset. Shadow of the Tomb Raider was tested with the built-in benchmark, and these are some of the best results I've ever seen from a laptop. Well, I guess it's not really a laptop if you can't use it on your lap, plus it'd crush you. Anyway, for reference at max settings, the mothership is even beating the Alienware 51M with 9900K. We'll look at how these compare soon. At 1440p, the frame rates are still good even at higher settings, still excellent performance here. At 4K, the results drop back significantly. However, 60 FPS was still achieved with the second highest setting preset, with almost 100 FPS still possible from lowest settings. Ghost Recon Breakpoint was also tested with the built-in benchmark. Starting out with 1080p, ultra settings was still averaging above 100 FPS. Again, extremely impressive results compared to the other laptops I've tested this game on so far. At 1440p, the frame rates dropped back a little, but 100 FPS averages was still possible at very high settings, and above 60 was still coming out from ultimate settings. 4K is pretty rough on this resource-heavy game, but the Mothership is handling it pretty well, with 60 FPS still possible at very high settings. Borderlands 3 was tested using the built-in benchmark, so the exact same test was done at all setting levels and all resolutions, and above 100 FPS was still possible with high settings at 1080p. At 1440p, there's minimal change at the lowest setting levels, and more of a difference at the higher presets, which are more resource intensive, though even at max settings, above 60 FPS averages was still being reached. At 4K, the frame rate at max settings almost drops in half, with medium settings now required to maintain above 60 FPS averages in this test. I've tested way more games in the dedicated gaming benchmark video. Check the card in the top right if you're after more results. Let's also take a look at how this config of the ASUS Mothership compares with other laptops. Use these results as a rough guide only, as they were tested at different times with different drivers. I've tested Battlefield 5 with ultra settings, and I've got the Mothership highlighted in red. This is the best result I've ever recorded from a machine like this. It was actually ahead of the Alienware 51M with desktop 9900K, most likely as I found the 2080 would run at 200 watts, so it had more GPU power. Here are the results from Far Cry 5 with ultra settings in the built-in benchmark. This time the 51M was slightly ahead in terms of average FPS, but it was only a couple of frames, while the 1% low from the Mothership was ahead. Either way, both machines are clearly on a completely different level from what I usually test. These are the results from Shadow of the Tomb Raider with the built-in benchmark at highest settings, and again the Mothership was out ahead here. This was expected given the GPU power limit differences between the two, and that this test at max settings is fairly GPU heavy. As we've seen, the ASUS Mothership is offering serious levels of performance, which is to be expected. It's a thick machine with an overclocked 8-core CPU and overclocked RTX 2080 graphics capable of running up to 200 watts. 1080p and 1440p gaming was no problem at all, while many titles at 4K ran alright too depending on setting level. Now for the benchmarking tools. I've tested Heaven, Valley, and Superposition from Unigine, as well as Firestrike, TimeSpy, and Port Royal from 3D Mark. Just pause the video if you want a detailed look at these results. I've used Crystal Disk Mark to test the storage, and the RAID 0 array, which is made up of 3 NVMe SSDs, was offering extremely impressive read performance. Lower comparatively for the writes, but still great numbers. 2 SSDs are Intel drives which are connected directly to the CPU with 4 lanes of PCIe 3 each, while the third Samsung drive goes via the chipset. The SD card slot performed fairly well with my V90 rated card too. For updated pricing, check the links in the description, as prices will change over time. At the time of recording, in the US, the ASUS Mothership with these same specs seems to be going for $6,500 US, though it's also available with double the storage and memory space if you're a baller. Meanwhile, here in Australia, the Mothership will set you back about 10 grand. It's clearly an expensive machine. So who is the ASUS ROG Mothership for? It's not really a laptop at this point, but more of a portable all-in-one desktop replacement. Obviously, it's going to be way cheaper for you to build a more powerful PC. And for most people, that does make more sense. I can only see this really being beneficial to a small niche group of people where having everything in one portable unit outweighs the cost. I know if I had to travel overseas with a powerful system, I'd prefer this compared to a PC case, monitor, keyboard and mouse, assuming of course I was made of money. You could argue a mini ITX system is still quite portable, and I'm right there with you. Especially when you consider you could get that plus a good gaming laptop for less money. So I think it really depends how badly you just want to pay for a ready-to-go system that has a screen built in, keyboard and touchpad included, with battery power that's going to offer killer performance. So to conclude, you're getting top-end performance from a machine that's still more portable than a traditional desktop at the expense of some features that you normally get from a normal laptop. The big downsides are of course the price and size and weight. Although it isn't too difficult to pack up and transport, the machine itself is 4.7 kilos with another 2 kilos for the 2 power bricks. It also gets extremely loud when in turbo mode, so if fan noise isn't your thing, you're going to want some decent headphones. It did still play very well in the lower performance modes while also being quieter. The unique Mothership design is a bit of a double-edged sword. On one hand, it's clearly offering excellent thermal performance when you consider the specs inside. On the other hand though, you can only really use the machine on a flat surface and not like a normal laptop. It's not going to work out on your bed or on your lap for instance. And that's due to the stability associated with the kickstand, and not even the fact that it'll crush you. Those are the major issues with the ASUS Mothership. Let's also summarize what's good about it. The all-metal build quality was excellent. The performance is undeniably awesome. Simply by enabling turbo mode, the 8-core i9-9980HK CPU overclocks to 4.9 GHz on all cores. And the overclocked RTX 2080 runs up to 200 watts, delivering extremely impressive performance. Despite this, thermals were kept under control due to the custom design and use of liquid metal. 1080p and 1440p gaming worked great without any problems at all, and even 4K gaming was possible in most games with just 1 or 2 levels below maximum settings. Considering the specs, I think it would be great to see the Mothership with a 4K 120Hz panel once those are available. That way you could still run high refresh rate at lower resolutions if you want. Despite seeing some of those screens at Computex earlier this year, they still don't seem to be available. The screen was excellent. No observable bleed during normal use, high contrast ratio, above average brightness, and good color gamut with the option of G-Sync. I really like that ASUS give us the option of picking if we want to run with Optimus enabled for better battery life, or Optimus disabled for best performance. Granted, at this price range, you'd also expect that it has all the bells and whistles. So to summarize my summary, it's cool, unique, extremely powerful, but is large, heavy, and costs a lot of money, making it only for a small group of people. I'm really interested to hear what you think about the ASUS Mothership down in the comments. Based on the price, it's clearly a very niche product. So is it something you'd consider? Let me know, and if you're new to the channel, consider getting subscribed for future laptop reviews and tech videos like this one.